Bismillahirrahmanirrahim. Assalamualaikum. My name is Ahmad Nawawi bin Zainal and I'm from Faculty of Mechanical Engineering, University Technology Mara, UITM. And I'm from semester 7. So today I would like to present my final year project. So the title of my final year project proposal is Attempts to Improve Energy Absorption Characteristic of Circular Metal Tube Subjected to Axial Loading. On this slide, I will explain about the introduction of this final year project proposal. So, on introduction, I will explain about the title first. So, the title is Attempts to Improve Energy Absorption Characteristics of Circular Metal Tube Subjected to Axial Loadings. So, as we can see, improve. What is improve? Improve is improvement, process, growth, goal, strategy, quality, and also efficiency. And energy absorption. What is energy absorption? Energy absorption is defined as the surface below the load displacement curve. So as we can see the graph at the below, we can see the load and the displacement. And what is characteristic? Characteristic is a quality, cost, performance, duration, and productivity. And for the circular metal tubes, what is circular metal tube? As we can see at the picture at the side, as we can see, there's a lot of circular metal tubes and subjected to axial loading. What is axial loading? Axial loading is defined as applying a force on a structure directly along an axis of the structure. Before I go further about this final year project proposal, so here is the problem statement that I already identified. Nowadays, millions of people are killed in road accidents across the globe. As vehicle production has risen, so has the number of collision and deaths. So the problem that I already identified is to protect all vehicles and moving components from major damage when exposed to impact load, or to prevent human casualties in transportation system when a collision occurs. So on this slide, from the problem statement that I already told before, here is the objective of this final year project proposal. So the main objective of this study are to improve the uniformity of the load displacement behavior of axially crushed tubes, predict and control the collapse mode in each corrugation in order to optimize the energy absorption capacity of the tube. Besides, the aim of this research is improving crash worthiness characteristics of cylindrical metal tubes performance. Okay, on this slide, I want to make sure that my final year project proposal is complete and successful. I did a research at the article. So I found that 4 articles that is related to my title. So Johnson W told that this energy absorbing device can dissipate kinetic energy in a wide variety of ways like friction, fracture, plastic bending, crushing, cyclic plastic deformation, and metal cutting. Besides, Hausen AG already stated that several attempts have also been made to improve the energy absorbing capacity of metal tubes by using filler materials such as foams, wood, honeycombs, and metals. These researchers have shown that filling cylindrical tubes with foam eliminates their non-compact crushing behavior under axial loads and significantly help to prevent global bending. Moreover, in comparison with empty tubes of the same size, foam-filled tubes are less affected by external parameters and are more stable while collapsing. For the third article that I found is from White and James, investigated the influence of several design parameters on the collapse behavior of thin wallet, top head, and double head section structures experimentally and theoretically. They found that application of top head and double head section can improve crashworthiness characteristics of thin wallet structures. And lastly, I found from article that from Abramovic A and Jones N. As a matter of fact, favorable crashworthiness characteristic for energy dissipation purpose can be achieved from axial collapse of tubes while they crash progressively. So I think from the four article that I already stated above, I already get the idea how I want to solve the problem statement and to achieve the objective of my final year project proposal. Okay, from the literature review that I did, I found out that the scope of the project. So here is the scope of the project. As we can see the picture that I already shown at this slide, as there's a car chassis. So I already circled where is the part that is very important when the crash happened. So this project takes the car chassis as the main reference and change to the simpler design to be used as a study measure. And also then the best solution is I change the design from the chassis car into the circular tube metal. So after all, I did a research and I found that two design that can achieve my objective of this final year project. So that is a two design that I already designed that I believe that can settle up this problem. So the first design I already shown that thin wallet tubes with expanding ring. Beside, the second design is thick wallet tubes with wide external groove. Okay, for this slide, I will explain about the methodology of this final year project proposal. So the first method that I use to complete this final year project is by using quasi-static compression test. For the both design, the first design which is thin wallet tubes with expanding ring, and the second design is thick wallet tubes with wide external groove, have to go through at quasi-static compression test. These tests are used to determine the material behavior under a load, the maximum stress a material can sustain over a period under a load, constant or progressive, is determined. Compression testing is often done to a break or to a limit. So for the first design, why I choose the first design is because the thin wallet tubes are made of aluminium and steel, and the length of the expanding ring range from 1/6 to 1/4. And for the second design, thick wallet tubes with wide external groove is made up from seamless mild steel tubes of commercial grade with an outer diameter of 60 mm and internal diameter of 52 mm. Okay, for the second method, to make sure that the experimental value is correct, we have to compare with the simulation method. So for the second method, I use FEA model test to find the analysis from a computerized method for predicting how a product reacts to real world force, vibration, heat, fluid flow, and other physical effects. FEA shows whether a product will break, wear out, or work the way it was designed. So that's the first design where I already did at the FEA model test. And also for the second design, we can see the after simulation. Okay, for the last slide, I will explain about the expected result of final year project proposal. So as we can see, there's two methods that we use. Then we believe from the two method we will come out with two results. Okay, for the first result, there's a table that come from the experiment of quasi-static. Okay, as we all know, the test pressure is to define the time and the displacement and also the load given. So from there we can know which design and which length can help achieve our objective. Okay, for the second design, as we can see, the first design method, a rigid steel ring is press fitted on top of circular aluminum tubes. When this arrangement of dissipating energy is subjected to axial compression, the rigid ring is driven into the cylindrical tube and expand its top area. Then, plastic folds start shaping along the rest of the tube length as the compression of the structure continues. In the second design method, White grooves are cut from the outer surface of steel stick wallet circular tube. In fact, this method converts stick wallet tubes into several thin wallet tubes of shorter length, being assembled together coaxially. When this energy absorbing device is subjected to axial compression, plastic deformation occurs within the space of each white groove, and thick portions control and stabilize collapsing of the whole structure.